Here we go. This is just what we, hang on for Katie Ford.
Atari and Robinson report to the guidance office.
All right, so here we go again. Just what we did in class today. I know it's difficult. I know it's a lot of algebra that we have to fight through. I know we were looking at slope in a different way. We were using f of x plus h as our y2 and f of x as our y1. I know it's annoying, but the formula is really important, and I think using that formula to find this instantaneous rate of change, which is our new thing. We're taking our pre-calc into calculus, and so I'm going to use this function here because that's my y is my f of x, right? And I'm going to just use it. We're going to talk about m, the slope or the instantaneous rate of change, as the limit as h approaches 0, because we want this value, the space between x and x plus h, to get infinitely small, and that's why we want to approach 0. We want to have a limit that's squeezing it together until there's no space whatsoever of this function, and we're going to use f of x plus h minus f of x all over that space that's getting infinitely small. Okay, and so I'm going to go ahead and I'm going to start inputting these values. And so everywhere you see an x, we just put this bad boy in here. So here we go. The limit as h approaches 0 of 3 times the quantity x plus h squared plus 4. And that's my first bit. And then I'm going to subtract from it just that 3x squared plus 4. And all of this over h. And remember what we wanted to do. We wanted to find a way to get an h factored out so we could cancel, just like we did with our limits earlier. We wanted to be able to, we can't input 0 here. It doesn't exist. So we want to find a way to factor out an h so we can cancel with this bad boy in the denominator. So let's do some math. If we go ahead and FOIL this, right, all we have to do is rewrite it as 3 times the quantity. X plus h squared is just x squared plus 2xh plus h squared, right? And then we'll close the brackets on this, and then we have what we had before, x squared plus 4, all over h. And I'm sorry this got real close. I'll rewrite it smaller up here. Okay, so all we have to do is distribute the 3, So 3x squared, that's really helpful. Look at that. Plus 6xh plus 3h squared. And then what did I forget? What did I forget like I forgot earlier today? Plus 4. Good job, Sokol. Plus 4. There we go. All right, that looks more like it. Minus 3x squared plus 4 all over h. Okay, I'm really close now. I see 3x squared minus 3x squared. So those go away. I see 4 minus 4. Those go away. So what do we have left over? It's 6xh plus 3h squared over h. Well, all I have to do right now is go ahead and factor out an h, because these two terms have an h in common, don't they? So I'm going to rewrite it right here. h times the quantity. Well, if I divide an h out of here, I have 6x left over. I divide an h out of 3h squared, and I'm left with 3h all over h. Well, now I can cancel, right? And that becomes 1. H divided by h is 1. So 1 times 6x plus 3h is good. Now I said, and I'm going to bring this all the way down here so I don't have to rewrite it 6 different times, the limit as h approaches 0 of this function. Well, as h approaches 0, now I can input this 0 for h. So 6x plus 3 times 0, well, that just becomes 0. So my answer to this problem, my slope is 6x. All right, there we go. That's the first one. I'm going to erase a little bit of it when I get lower on the other side. Okay, or maybe I'll erase later. Nope, I'll erase it because I'm going to need the space. So now we know that the answer to this first one is 6x. Let's go ahead and do it with this bad boy right here. The only thing that's changed is there's another x in here. Right? Uh-oh. We may have trouble, but hey, let's see what happens when we do this. If we go ahead and put it right into the function, the limit as h, not x, Harry, h approaches 0, and we'll just go ahead and put it right in, -2 x plus h squared plus 4 times x plus h. All right, and then close that bad boy up. There's going to be a lot. I will not have enough room. So I'm going to get rid of this guy. That's just a little reminder for me over here. All right, and then I'm going to subtract 2x squared, -2x squared minus or plus 4x. Okay. So far, so good? Great. All right, if we FOIL this, we have -2 times the quantity x squared plus 2xh plus h squared, right? And then we're going to add to it. And I'm just going to go ahead and distribute here, plus 4x plus 4h minus -2x squared plus 4x. All right, and all of this is over h. And I did have this over h, but I didn't write it. I apologize for not writing that. All right, so now we're going to go ahead and distribute the -2 to everything. -2x squared plus -4xh plus -2h squared plus 4x plus 4h. Quantify it. Minus -2x squared plus 4x. All right. Now, there are a couple of things I can get rid of, right? This guy right here and this guy right here cancel out with these two things. And so let me rewrite all of this. What's left over? -4x h plus negative 2h squared plus 4h all over, all over h. Look at that. All three terms have an h in it. So let's go ahead. Go ahead and factor out our h. So h times the quantity, negative 4x. Woo, a lot of work. Plus negative 2h plus 4 all over h. Those two things cancel. And what do I have left? Negative 4x minus 2h plus 4. And if I go ahead and plug in 0 for h, I get negative 4x minus 0 plus 4. That's my final answer for that. Okay? Looks great. You guys are doing great. This is a difficult one. It's a little bit more extended, right? And then I'm going to do the cubic function because that one took a long time. And I have it sitting over there, and I'll have a little reminder of what we get when we cube x plus h. Because having formulas and templates are what make life great. So let's go ahead and do it. So the second one was the limit as h approached 0 of y equals negative 2x squared plus 4x. Our answer, our y prime, or our m was, what we have, negative 4x plus 4. All right. And now we're going to use this guy. Y equals x cubed minus 6. All right. I need to put a reminder up here of x plus h cubed. What comes out when we cube this? X cubed plus 3x squared h 3xh squared plus h cubed. That's what we get when we cube it. Okay, so remember that. That's going to help us. So here we go. The limit as h approaches 0 of our function. So we have x plus h cubed minus 6 minus x cubed minus 6 all over h. Right? I told you there's the template that we're going to use. So we're just going to write it out using that template. X cubed plus 3x squared h plus 3xh squared plus h cubed minus 6 minus x cubed minus 6. All of this divided by h. All right, that's a lot of work, isn't it? It looks awful, but we are so close to being finished. Look, I have an x cubed and a minus 6, an x cubed and a minus 6. I'm subtracting them. They go away. So what's left over? These three terms all over h. Okay, well, we have 3x squared h plus 3xh squared plus h cubed all over h, and we're still talking about m being the limit as h approaches 0, right? Still holds true, still holds true. Now we see each of these terms has an h in it. So let's factor it out so we can cancel here. So I'm going to write it right next to it. H times the quantity 3x squared plus 3xh plus h squared all over that lonely h. And as h approaches 0, now that this is canceled out, now I can input that 0 here and that 0 here, which makes both of these terms 0. And what's left over? 3x squared. We have done our job. So I'm going to show it to you just because. 3x squared plus 3x times 0 plus 0 squared. Right? These two things go away. I'm left with 3x squared. And just like I showed you in the beginning of class, if we used the power rule, we would throw this power to the front, and we'd have a 3, and we drop this power by 1, it'd be 3x squared. If I use the power rule, I would multiply -2 times 2 and get -4. I drop the power by 1, it'd be x to the first. I would multiply 4 by 1, drop the power by 1, x to the 0 power is just 1, and we just lose it. And last but certainly not least, I would multiply by 2, I get my 6, I drop the power by 1, I'd have x. So if I use the power rule, it gets me there so much faster. But to understand how we got where we got, using the slope formula, y2 minus y1 over some x value that's getting infinitely small, this is how we use calculus. This is how we use algebra to prove our calculus, by using that limit. You have done a great job today, and I expect more tomorrow. We're going to do stuff just like this. So if you watch this and watch it again, we can